Hello and welcome. I'm Bill Wake. We're here working on a program to compare tunes for similarity. And one of the things we want to do is consider the most frequent note at each point in a song and mark those for now and eventually maybe draw some lines around them. Okay, we're starting a touch late today. I ended up with a doctor appointment and just got back, so we'll go a little late too. Okay, let's go to the IDE. All right, let me run. I just ran tests, so we're good there. Oops. Okay, so we're going to take this no-scaling ABC, no-scalan, I'm never very good at saying it, and our melody average. Okay, and what we're going for is this shows the first measure, first note, first measure, second note, and so on. And we quantized it, so we set it to quarter notes only. It's a little odd, there's 6 beats, but that's the way some of the inputs are. But at any rate, we've got the counts for every measure, basically, every note in every measure at this quantized level. And we want to know what's the most frequent starting point. And in this one, we can see it's the 5th of the scale. So do, re, mi, fa, sol. Okay, so if you think of twinkle, twinkle, it's twinkle, twinkle. That's the 5th. All right. And no-scalan is like deck the halls. So it's deck the halls with boughs. It's going down, 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 down. And we can see that pretty much here. Here's the most common, here's the most common, same note, goes down, skip the blanks, and goes down again, okay? And then goes da, 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 So that's the general shape of the melody. And what I'd like to do is probably, I don't know, maybe reverse this square so it's dark green on with light yellow print, or light gray, or whatever that is. And, it's the most frequent. Do that for each most frequent one. And I think having one square highlighted in each of those will be good, except that it's not always one. Sometimes you can have 2 notes. The 2 or the 1 is equally frequent in these 39 versions of Deck the Halls. I don't see any with 3 that have the same, the most, maybe it is. Nope, there's a 6. Okay. If that 6 were a 5, we'd have 5, 5, 5, 5, 4 different places. So it's certainly possible. Now, okay, so this view is organized by rows, kind of unfortunately, I have to say, but that's the break. That's where we are. We don't have a grid that seems quite suitable to do it the other way. We tried that lazy H grid, which is fine to do things kind of in columns, but it has its own way of laying out, and it just didn't seem like a good way to go. All right, so we have the data organized by scale degree, then by measure, and then by note number. And so we're going to go through, for a given measure and note number, count up all the possible values for these. Okay, and I think, well, let's see what we got. You'd think I'd remember the name of this file by now, but I don't. It's average something. Average tune stage, that'll get us there. Okay, where's tabulator? Yeah. I guess we changed it a couple times, so it's even harder. All right, so note tabulator is the thing that its job is give me a bunch of tunes and I'll go through and record the statistics of them. So I do that by populating the statistics tune by tune. and walk through the measure numbers and populating each measure. And that's really each note in the measure. Okay, it's symbols or notes or rests. Okay, and it increments this value. So that value is, well, it's a three-way subscript. And if it doesn't have anything in that place, it returns 0. Okay, but let's see. Here, I guess let's start with the data structure. Here it is. It's three-dimensional. So first dimension is the scale degree, do, re, mi, basically, numbered 1 through 7, 1 through 7 plus, and so on. Next, the measure number, and then the note number within the measure number. We know the highest measure and the highest note by the time we go to make the real statistics. Okay, so it's like, how are we going to keep track of that value? Well, either we keep it outside this structure, or we put it in something inside the structure. And I think this note count might actually be the place to put it. So let's go look at note count. And note count, well, right now it's the actual cell contents. So let's go back here. This 12, there's an entity that's got a note count with the value 12 in it. All right. So what I'm proposing, I think, is let's keep track of whether it's a most frequent value. It's really the mode, statistically speaking, but that word is so overloaded. I just don't know. I think is most frequent is probably okay. Now, the reason I'm doing it cell by cell is, like I said, there may be multiple, and if there can be 2, there could be 5 or 10 or whatever. We don't know. So we're going to mark each one of these as being the most frequent value. This one is only 1, 1, 1, 1, 1, 1, 1, 1. Okay, there only is one most frequent value, but it certainly can happen, so we'll need to allow for it. All right, and I think I'm going to just say public let is most frequent be Boolean. And let's see who cares. The ones in our code, we most likely have to set it. We might want to default it for the others. Okay. Well, we can certainly start it out false. We'll let it insert it. Is most frequent, and I'm going to start it out false just to get the value in there. Now, I suspect there are some tests that will also care. But right now they're not. Oh, no, they don't. Okay. Well, I guess they don't ever create note counts. They call make to do it. So, good. All right. So we added an unused is most frequent flag to note count. And I've been thinking, what we have that note count, and all it is ID and count. Well, it was, but we could also, we could foresee maybe wanting more information someday. Like maybe it would be nice to know which songs, which versions had that note at that position. And that would be a reasonable place to attach that. So I think it's a little weak to be one field, an int and an ID, but maybe this is more justified than I originally imagined. Okay, so now let's do some tabulator tests. Okay. All right, I think we can do this. We'll start, okay, we got tunes. Let's, right, so the most frequent counts, test, you know, most frequent count. I guess that's maybe all we need. So what we want to do is go through, well, I think we want to go through the number of rows. Well, we want to go through and do the tabulations column by column. This one, the most frequent one is 2, 1, 1, 2, 1, 2, 1. Okay. So actually, well, yeah, I'm okay with that. All right. So we count the rows, count the tabulator, populate the tune, and now we're going to ask. So we want to say, well, what are we after? We got the table populate. We really want to know for a measure. Well, this gets at the difference between our thing, between the note tabulator and the view stuff. Okay, so note tabulator makes a tune counts. All right, this thing, well, yeah, it's almost like, how do we need that there? Okay, let's drive from the front end for a change. I think because we're generating a new, well, we have new information want to pull from this. I think we can fake it here and work on the display and get that all right. Okay. Most things, right now, everybody says frequent is false. So we don't really have to do anything there. But I think we could, let's see. So it's the notes. We could do, is it bool.random? Okay. We'll get a random on or off there. Okay. And so let's go look at average tune view, average think view. Okay. This thing draws the cells here for each column count. Oh, that's the columns. Okay, here's the grid. It asks for scale degree counts, and it gets a count, and that should be note count. Okay, and so the foreground color, well, I want to say, if the count is 0, the color is light 1. Else, if else count dot is most frequent. Come on. Is most frequent, then let's do color dot color of light gray. Else an accent color. Okay, and the background color, we want to look at the same thing. Count dot is most frequent. If that's true, now I was saying I want to do this. If it is most frequent, let's do color of. Now is that backwards? Foreground is like gray. Okay, yeah, color of accent color. Else doesn't like my formatting. Do that here too. I don't know. I'm just playing with it, but I think to me it expresses what's going on here a little better. Okay. And we'll just make sure this is not, it's potentially problematic. All right, I'm going to move this up just so these two things are next to each other. All right. So if it's most frequent, we have light gray on accent color, otherwise accent on light gray. All right, let's see how this looks. Parsons, scan, quantize, and melody average. Okay, well, in real life, I don't want to mark zeros as being the most frequent, but I think in terms of compelling colors, I think that will show up nicely. It may be a little too strong even, but there's only going to be one in most columns, maybe two. Okay. So I think that's progress. Okay. So let's do this. Display, well, average sync view shows most frequent values with a highlighted color scheme. Now, I'm thinking this is complicated enough. We should extract a method. So let's do that. Okay, and this is function. Well, let's call it foreground. Returns color. And we're going to extract this into a method. I wonder if it'll let me. You just never know. No. Okay. Oh, it did. Okay. He should have complained. All right. But we'll let it go. Okay. So we have the note count. We don't need the return if it's the only thing. Okay. If count is 0, then light 1. Otherwise, if count is most frequent, then light gray. Otherwise, accent color. Okay. And foreground passing note. Let's see if we did that. Yeah, that's definitely acceptable. Okay, and then let's do background. Why they don't call these the same? Like, all right, well, let's take this anyway. Background coloring. Maybe we'll make those names match. Okay, background coloring. Most frequent, yes. And Okay. I suppose I will. We shouldn't see any difference. Yeah. Well, the random values may be different, but the color scheme should be the same. Okay. So refactor methods to decide cell color. All right. And then back to note tabulator tests. Okay. Well, what we want to do, right, scale index, row G, row F. So what we want to say is row G counts. Let's just take the first couple and make sure they're different. Okay. Count. Count sub 0 dot is most frequent. This is G. This should be true. And row F is most frequent. Should be false. Okay, because the cell in there, first measure, first note is false. Okay. And then let's check another. Now these ones that are 1, that's sure wimpy. I'm going to make this, we'll make a different test for the case I wanted to look at there. Okay. This I don't think we need, but let's look at slot 1, because that one is most frequent true, but this one should also be true, because here most frequent is 2. Can we see? Yeah. Most frequent is 2 at the first slot and 1 each at the second slot. Okay. Now, the problem with this one, well, okay, I think that's fine. All right, now this test should pass. No, we haven't implemented it yet. Yeah, okay. It randomly set this to true. Remember, it's all random at this point. And randomly set both these to false. Okay, I guess. And implementation. All right, this is going to be trickier. The problem is we can't create note count. We're going to have to know the most frequent number first before we come in here, I guess. Right. So I guess we're going to do the same row number and 0 to count. Okay, I think that is backwards for what we want. We don't care so much about the scale degrees. We're counting vertically. Give me your biggest number. Okay, so I'm going to write a loop, I guess, that says for row number, no, for measure number and note number. Okay, we need those two. All right, and let's end. All right. Now we are not generating the IDs yet. Let's move this down. I feel like this whole method probably should be split, but that's another story. Okay. So I need okay. So what I want to do is run the scale number, row number here. Okay. So for a given measure, for a given note, I want to find out the maximum across the scale degrees. Okay. So a little weird on the order front, but now if I access this, okay. I want to find the maximum. All right. There's no maximum value there. Let's do var max equals 0, since the lowest it'll be is 0, and it will. All right. And then let current equal that. Okay, so get the value. And then max equals, well, maximum. Max of maximum and current. Okay, so for a given measure number or note number, we start with 0 and then we find the biggest number in the cell. Okay, we don't care if there are two of them, we just care which one's the biggest. All right, now we need to save that value. Okay, now here we got scale degrees, sorry, counts. Okay, these things are used in the same order. I think that'll work. Let's accumulate, let max values is array event, starts out empty. Okay, so at this point, right, from these, we know the maximum for this cell, this column. All right, so max values sub dot append maximum. All right, so at this point, the indexes here are going to correspond to the indexes here. And they, is that right? Counts, note count. I think we're okay. All right. So if we've run through this, we calculate the maximum for each column, which is measure number plus note number, indexing it. Okay, and then we append that. At the end of this, we have a list of maximum values for each column in order, the same order that we're going to get them out of here. Okay, so before we append this, counts, the index we want to access is counts.count. Okay, so let max value equal counts dot, sorry, what did I call them? Max values counts.count. Okay. Okay, so the max value is the number here corresponding. So when we first come through, counts is 0, and we want to pull item sub 0 to find the maximum for this column. Okay, so we haven't actually, it's sort of, I don't want to be off by 1. Okay. And then most frequent, well, that's not going to be bool.random, clever as that is. It's going to be, well, if I guess we'll have to know if it's 0 or not. If it's 0, we don't want to make it the max, okay? So it's the same as, well, if the, when is it true? It's true when the count, okay, let's extract this. Come on. Okay. That's going to be the cell count. Is that. Okay. And it's the most frequent when if it's true, if cell count is max value and cell count not equals 0. Okay, so if it's 0, we don't want to be the most frequent, because if the maximum is 0, everybody's 0, and that's just too boring to draw. So I think that's okay. And I think that's what it takes. Okay, so let's run unit tests. They should pass. Oh, 3 failures. What's going on? Oh, okay. Yay. Okay. So we are calculate mode. Well, I've been saying most frequent value for each count. Okay. And I guess I should make that, tell you what, let's do this and get that last one. Okay. 0, 1, 2, 3, 4, 5, 6. Let's go for 7. This should always be false because 7 has no notes, so everything's a 0. And I went a little further than my test there, so let me back that out and make sure make sure this is okay. So let's take out this clause for a minute. Test should fail. Right. They, if you don't have that clause, they get marked true. Okay, and undo. And they should pass. Okay, and we'll run it. Now it should look right. Okay, I believe we're functionally done. I want to do some refactoring still. Oh yeah. Where's that 1010? Yeah, they're both marked. Okay. Anybody else with 2 in the same column? There might be some 1-1s out there with that, but I don't think there's going to be 3. Yeah. Those songs, everybody's the same. And then we drop down, we've only got 2 songs left this long. Then we only got 1 song that goes to measure 27. Okay. That's a little misleading. I mean, I could do something that says if there's 3 values that are most common, maybe that's okay, but 4 or more, like values of 1 or values of 4 or more distinct, 4 or more things with the same answer. Maybe some rule anyway that says if we have too many of the same, it's just too boring to mark them all. Now, that's interesting. That's there. Okay. But I think in terms of what we're after, okay, and our zeros get left out. Good. Well, I think that one's done. Somewhere I'm going to wonder if there's 2. So I'm thinking about drawing lines now. If I draw this line, this line, this line, and maybe I don't need a line for these 2, and then this line, this. Do I really want to draw this line to 2 different values? I don't think it makes sense. So maybe if there are multiple values in either the source or the destination, we shouldn't draw lines, because otherwise I had to draw both pairs and then both pairs here. And I don't think that's visually going to be too helpful. So I don't know if it's even needed. This pops out so well, it practically is a line. Yeah, you know what? I think we're going to let that one go. I mean, it's a thought, but it's so well defined visually. More interesting to me would be like, why is this going on? You know, I mean, we know why, but the reason is there are some measures that are in like 6/8 or 6/4 or something, and they've got 6 actual quarter notes. Okay. Yeah, I mean, that looks good. Again, I haven't run this by my customers to see the result here yet, but I think she's going to like it. Okay. It's very visual. Okay. And refactoring, Well, one thing, what this is doing, the whole thing produces max values, so that should be very extractable. Come on. Do I have to? Ah. Okay. Well, I'll extract it. Private function, find max values. It looks like it's taking nothing. It's only using stuff from self, but it returns an array of int. Okay, and here we'll return max values. Okay, and then this can be a let max values equals find max values. I mean, that reads a whole lot better. This now uses max values and a bunch of individual stuff to produce a tune counts. Well, the rule that says these should be at the same level of abstraction kind of says I ought to make a separate routine for this too. Okay, so this, okay, and this is private func tabulate counts. It's going to take our max values and it's going to produce, well, tune counts. Okay. All right, so this, well, I guess that all goes. Return tabulate counts of max values. Okay. Yeah, it's a little better. I don't know. Like at some point, would it make sense to break out the little loops separately? But I'm going to stop there. All right, make room increment. Yeah. Okay, compute the modes for each column. Well, we've done both these. Let's see, this was all melody average. And this is melody average. Good. All right, draw the line. I don't think so. Only show from the first row with entries to the last row with entries. I don't think we're going to worry about that. Now, things I've realized, wait, metadata show each, oh, metadata, okay. Yeah. So doing this, having like that measure 5 and 6 or beat 5 and 6 show up, what that reflects is that we don't do any filtering on time signatures. And I haven't really quite got my head around what we want to do. Excuse me. What happens is everybody gets their own time signature. Let's go open no scan. Okay. So time signature is M. All right, so we'll start at the top. You actually have to have an M. It's a required field. And this one says C, which is common meter or 4/4. This one is 4/4 written out. 6/8. Same. 4/4. 3/4. 4/4. 2/4. Okay, see, they're all over the map. 6/8, 4/4. I don't know if there's a 6/4. There's 3/4. Okay, so what happens is, well, the 6/8 meter, when it gets quantized, right? It's only, if you divide 6 by 8, you get 3/4. So there are only going to be 3/4 notes in a measure of 6/8. And so we're kind of mixing all these ones with 4/4 notes in the measure with these ones with 3/4 notes in the measure. So, well, I guess we can look at the data and see it. I mean, this is our visualization. What I expect to see when I quantize is that the count for the first three is going to be the same, but the count for the third is going to be short. Okay, 12, 15, 18, 21, 31, 32, 36, 37, 38, 39. There are 39 songs. 3, 5, 6, 10, 18, 19, 25, 28. Interesting. A lot of people don't seem to have a second note. 3, 4, 5, 6, 17, 19, 20. Okay. Some don't have a third note. 2, 4, 5, 6, 7, 16. That's the least of all. So all these ones that are 6/8, they don't have anything to contribute to this column. And I don't know if that's good, bad, or what. What it makes is it's misleading. Okay, that we're mixing these meters. And so one idea I have is filtering. So you would give me, in this case, we want to filter time signatures. You would say, let's see the 2/4 ones, let's see the 4/4s, let's see the 6/8s. Okay, and you would filter those out separately so that they would be consistent. Because, I mean, it's pretty obvious if one person's singing 6 notes and the other's singing 4 notes, it's not going to line up perfectly. Okay, and mixing and matching is probably confusing things. But so one idea of filtering. Let's capture that. All right. Well, here's more ideas, but one idea is filter by time signature. Okay. And another thing with that is, well, how do I know what the time signatures are? It would be nice to see, I don't know, this is counts by time signature. Okay. Those two would let me, I could then do a analysis that says what are the time signatures, and then go back and select just those if I had these two capabilities. Another approach, well, limit notes per measure. Yeah, this would be take the quantizer and tell it quantize by quarter notes, but I don't want to see more than 4, say. Okay, but that's kind of throwing out mix and match information, so it's a little misleading. So I think that's actually not a good idea. In effect, I'd kind of write, if you had A, B, C, D, E, F, I'd be rewriting that to A, B, C, D. Well, who says E and F are the least important notes there? It might be that A, C, and E, every other note might be much more important. And leaving out the last couple would just be arbitrary. Okay. Now, limiting the number of measures, that I think is okay because you're saying, if there's similarities, they're going to show up in the first 24 measures, say. And we don't need a table that goes out to 48 when it's only one or two songs that go that long. So I think that thing might be useful, again, just to kind of unify things a bit. Now, the other thing I think of is, and I don't know what to call this, but it's like a time signature warper. And what it would do is convert 3/4 to 4/4 and convert 6/8 to 4/4 and stuff like that. Okay. Or 4/4 to 3/4. Okay. Could go the other way as well. And there's no, well, it's definitely a variation to convert something in 4/4 to 3/4 or vice versa. You're changing the flavor of things. So I help teach a kids group dulcimer, and our teacher sort of the total leader teacher recommended, hey, there's this Mozart variations of Twinkle Twinkle Little Star. And he made 12 variations of the same song, and we should be trying stuff like that among ourselves, And I think one of those variations is 4/4 to 3/4, like dun 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 dun, or something, but not Twinkle Twinkle Little Star. And it's a legit transformation. And unfortunately for us, you have some choices of how to do that. I mean, like, okay, let's say I have ABC. I can delete these. Okay, you have ABC and you want to stretch it into 4 beats. You could go A, B, C, C and just kind of, stretch out that last one. Or it might make as much sense to go A, B, C. I don't know. It could even make sense to go A, B, B, C. There's nothing inherently in there that tells you what to do. Or it may be, sometimes it's done basically each quarter note is broken up into 3 notes, and then it should maybe just be A. Okay. I don't know how to specify this, so the odds of me implementing something useful are probably slim. And this is probably one where if this is needed, I probably need to talk to my at least one musicologist and make sure that's really useful. Okay. It may be the filter and count thing is far more useful. I mean, I definitely can see wanting to filter. There could be, there are lots of things going on here. We could filter on any of them. The title, you might have a bunch of songs with different titles. Okay. Unfortunately, these no scaling ones, they don't line up. Okay. You might want to look at the ranges or the keys, the meters. I don't know if L is super interesting. T's title, this is a reference number. N is notes. And this is, I think, the collection it came from. Yeah, that sounds likely. Anything else interesting? Key. It definitely would be interesting to know the key signature, but mostly the kind of analysis we're doing, they shift it so it's talking about the first note of the scale, not is it a C or a G, because G in key of C is the 5th note of the scale, but G in the key of G is the first note of the scale. So it's you can't trust the letters by themselves. All right, but it'd be interesting to me, like, oh, there's an E flat. That's really odd. Okay, it's an A. I'd like to know the ranges of possibilities. So this next one is, I think I may have already written it in here, statistics. Well, um, yeah, this would be kind of like show number of entries per item, e.g. key sig. Okay, so this would be listing out all the key signatures and yeah, so list out all the key signatures, tell me how many there are of each. Okay. Or maybe only list the ones that actually occur. Okay. Um, Either one's possible. Okay. And I think you can do this for anything. I mean, you could say, a lot of these share the same title. I don't know if they do. Woodless. No. I mean, unfortunately, they're all different, but that's worth knowing too. Um, some of these have kind of funny lyrics. Okay. Okay. Well, I have to say, these titles do vary more than I expected. The old melody. Okay. um, but it would be nice to see them just listed. Okay. So I guess this would be title. Now, we don't do everything. There are other descriptors, we'll call it A and O. O is origin. I guess if it's there, it shouldn't be here. Origin, and you do that hierarchically. So you say like, like I'll do the I'll do a U.S. one. So U.S. Nebraska Omaha. Okay, you'd put U.S. semicolon Nebraska semicolon Omaha. Say okay, and that would define a hierarchy. And then it might be interesting to see these things hierarchically. So how many tunes come from North America versus Europe, and which state and which city or area. The London ones often, well, maybe I just don't have the geography. She doesn't have origins in this, so. But we'll see. This is collected in some little village that's really technically part of London or just outside it or something, and it's interesting to know which parts of things it's there, where things come from. Especially from the musicology side, right? You'd if you saw two very similar songs from the very similar area, you might think, oh, or is everything in this area done the same? And check that out. All right, so some of these now, she's used slash here. I thought I thought semicolon was kind of the normal separator, but maybe this is just that. No, it's not a translation then if it's that way. Yeah, that's definitely not. So, yeah, I don't know. You might find slash being a separator. Maybe you have to say what the separator is. Um, in this file, it's certainly slash, isn't it? But some of these are translations, so it's hard to know. But they're not hierarchical. There's no bunch of aperitif and then some are cardigans and some are corduroys. Now you might want to combine this filtering. You probably could we could maybe develop an interface that combines these. So you could choose yeah, maybe you could choose the count. Like what are you going to look at? I'm going to look at time signatures, and it's going to come back and say there's 2 4 3 4 4 4 6 8 9 12 whatever 9 16, and then give each one a little checkbox and let them include it or not include it. Okay, so I think that would be a noble cause. What else we got? Count, metadata, occurrence, and show counts and values. That's kind of also that same thing. Statistics report. Yeah, that's really this. Okay. And maybe count and filter is enough to, or explore and filter. Maybe just the word filter is enough. Okay, that makes me wonder, do we have a funnel in here? Let's see what they say for filter. Camera filters. Those don't say filter to me. Funnel. Whoops. No funnel. Oh my gosh. Well, pencil tip upside down might do it. Let's go through and see what we see. Maybe some sort of arrow shape. How about count? It's all counter. Okay. Number. I think there's a 1, 2, 3. Number dot square, number dot circle. We've got that for our statistics, I think. I'm just looking for anything that looks filter-like to me. See something with an X? I guess not. I could be. Well, the other one that I saw was up here. Something just arbitrary checkerboard might be okay. I'm sure there's a downward triangle. It's funny how you think something's a pretty well-known convention and it doesn't show up in here. I guess checkerboard's kind of arbitrary, but okay, there's triangle, arrow, heart down. Okay, so another word to try is select. Select triangle. I like these little magic wands. Does light stay filter? Not really. Excuse me. I'm probably looking in the wrong place. I probably should just look online first and see some possibilities. Comb maybe is a little too something. Now, comb.fill, if there's an upside down version of that, I'd take that. Well, we're getting to the bottom here. Okay, well, there's a triangle down. Maybe triangle down is enough. The numbers. Okay. Triangle. There aren't a lot of down ones. Down circle. Down square. Select. Okay. That triangle down will work for now, or checkerboard. All right. So the design I have, well, that was this analysis. Like, how do I match these things? And I could match them by strings. I don't care about paths. The time signatures, yeah, that's just a complicated question. I mean, another thing you sometimes want is what they call things in duple meter versus triple meter, where duple is divisible by 2 and triple is divisible by 3. Well, 6, 8 is ambiguous in that sense. You could look for a numerator divisible by or something like that. All right. So if I had something that listed these out by values for the meter. Okay, M is meter. It listed them, it puts a count and a checkbox. Okay, I think that's a start. All right, so filter and count and statistics. It's kind of the same. Okay, and then I don't know. Okay, we'll save that one for later. Okay, quantizer limit measures. I think that's a relatively lower priority than this thing. Tune creation for tests. This is, I think we may have made, well, we have different ways to create tunes, and I think some of them might be able to take advantage of, like they can take advantage of the whole input format. Since the whole format is designed to write tunes in text, it seems silly to build them up by measure in some cases, rather than just doing the equivalent of a mini instance of this would be perfectly fine for many cases. All right, but for now, and I think this will be a transformation, and I think it's a filter. Let's create the stage for that, and that'll probably take us to 3 o'clock and a wrap. Okay, so we have a new stage, and I'm going to start on the UI side again. All right, so this is a transform. Quantize. New group. Let's call this filter. Okay. And what's this view? Okay, well, that's its own view. Yeah, I think we're gonna have to do the same. So let's take this and drop it over here. Oh, can't quite do that. Okay, let's take this. Da, da, da. New file. Oops. Swift file. Filter view. And John Reed's been convincing me to drop this stuff out and only use this if we need it, which we do. Okay, this is filter view. And it's going to need a corresponding stage with a transform in it. Okay, so again, take this out. And we will select this file and make a filter stage. Okay. Filter view, let's have it take a filter stage. Now, that should still be okay. Filter stage. Okay. Now this is active false, that's fine. I don't know why we would need these. I think we said triangle dot down was our best. Yes, it's a stage transform. Let's just do a null transform, just return the packet. Well, this line is probably worth keeping. Okay, so we don't need a quantizer function, that's for sure. Okay, that all looks good. Any complaints here? Right, source is filter stage. Let's give it some filter text just for something to look at. Dot string. Yeah, string just doesn't need anything, I think. What does he want to format her? Value format. None of these sound right. All right, we'll take this out. For now. Okay. All right. This should build. Who's complaining? Source is filter. Oh, there should be filter setting. Filter view. No test should be complaining. All right, and then let's add that to the pipeline. That's been a while since we touched one. All right, well, this is harmless so far. Add filter stage and filter view. Okay, and then where's the pipeline? Pipeline. Well, let's take that out since we're here. All right, it's really content view maybe. Yeah. Okay, we still don't have a good way to do this. All right, so pipeline body text view. Okay, let's put the filter in there. If filter dot is active, filter view source is filter stage. Oh, filter by itself. Okay, and then filter needs to be a state object. So we're creating a class object here with this. Okay, and then the pipeline body is going to display each thing. Can't find filter view in scope. Well, you should. Okay, well, let's save that problem. Okay, now pipeline selectors. Jump there. Okay, that's the left-hand column there. Okay, so let's add a filter here. Filter stage, and we'll add it here. And here. Stage filter. Okay, the caller needs to add that in. Can't find filter view, can't find filter stage. All right, let's do a clean. Yeah, and build. Well, run test should build. Huh. Why can't you find that? Okay, I probably didn't put it in the right place when I added it, maybe. Sync transform filter. All right, let's take a look here. TuneSim should be in both. Should be in both. Okay, so that's successful. Still complaining. Yet it successfully built and ran. I don't know what to tell you. Okay, there you go. All right, let's run it. Now it's a do nothing thing at this point. So there it is. Okay, that name must have been bad. Was towards the bottom here somewhere. Arrow triangle dot down. Arrow triangle dot down. Yeah. Okay, I don't use it, so I don't know why that's a problem. Well, I meant to run it. Okay, so here's filter. I could ask for a better icon, I guess. Filter by and no contents. All right. I think that's a good first step. Let's check our stage. Active filter text, we kind of think we'll need, but we haven't done anything. Filter, arrow triangle down, that's good for now. Transformation, and then the transform. Okay. I think that's pretty good. A good start. All right. So what's it going to look like? Where's to do? Let's. I think filter stage and filter view. Let's close this. Okay. If tests run, let's push it. Add a no-op filter stage. Okay, so what I'm imagining is you're going to select the field. Select field, and that's going to come from the metadata. Okay, and then I think you also need to have filter text. So I could select 3/4 and it would limit it to that. Okay. Then I expect to get a list of all values for field filtered by filter text alphabetically. Okay. So let's let's fill in some of these things. So select field, we can hard code that to time signature for now. Okay. Select field, hard code to time signature. Filter text, omit for now. List all values for field alphabetically. Then list all values for field with count alphabetically. I can believe you'd want to sort by those two different things. Okay. Add filtering, add field selection. Now I'm gonna have to see what Tune does. I know we have metadata. I don't know who goes in there. Strings, lists, paths, or URLs. Okay, that's ID titles and parts. Okay, I mean, this is the thing that's going to provide us the selectors. We're going to take keys alphabetically sorted, I guess, and that'll be the list. And this is all kind of top level as list. Okay, well, this could be definitely sorted. Okay. We don't have meter in there. Oh, they are complicated, aren't they? Okay, so that's not metadata. That's really tune data. That may be tricky to select them both. Now, we don't even know what gets recorded. Okay. Well, let's look at the parser. Meter parser. Tunes.set meter. Okay, what do you do with that information? Set meter. Set initial state. Now the meter is so tricky. We're not, I don't know what are we keeping around the initial state? We're going to have to pick up there tomorrow. We'll figure out where are we going to get this meter from. I know it's put on each measure by measure, what its meter is, because you can change them. But I think we're just asking for the initial one, which does seem to be put somewhere. I mean, there's initial state.meter, but I don't know if initial state is maintained anywhere. Okay. Where's, okay. Meter parser, right, set meter. Back here again, coming around, initial state. What happens to initial state? event to parts. Okay, that's the class we extracted. And it certainly knows the initial state. What it does with it, oh, it starts out here. Okay. I think we can find it somewhere. Maybe we just go to the first measure and that's the default for now. All right. Anyway, we'll call that a wrap for today. Tomorrow I should be back at the normal time, which is 1 to 3:30 p.m. Eastern Time or 6 to 8:30 p.m. UTC. Thanks for joining today, and I hope I catch you in the future. Bye-bye.